Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. So for today's session, we're going to look at integration under the topic of Gauss quadrature. So how do we apply Gauss quadrature to get an approximation of an integration? The basic idea of Gauss quadrature is basically we need to change the domain. We need to change the domain of integration from xo to xn. For example, if you have function of for 1 square root x dx, so this xo is 1 according to the lower limit, and xn is the upper limit, which is 4, to natural dimensionless coordinate with a limit of -1 to 1, meaning that from 1, 4, we're going to change the coordinate limit to -1, 1. So from here, if let's say this is the original, just now we use 1, 4. So we're going to change it to -1. Okay, that is the first basic idea. We're going to change the upper and lower limit from xo, xn to -1 and 1. Which bring us, so if let's say this is the y-axis, so after we change it to dimensionless coordinate, the curve will become phi zeta. And if let's say this is the phi zeta, so the area under the curve here from I, it will become I zeta. For Gauss quadrature, we will have 3 cases or more, in which for our syllabus we're going to look at Gauss quadrature 2 points and Gauss quadrature 3 points, whereby for 2 points it is shown here, 2-point Gauss quadrature, whereby for 2-point Gauss quadrature you will have 2 value of x zeta. So let's say because it's a 2-point, so meaning that we're going to have zeta 1 and zeta 2. So this is actually x zeta 1 and this is x zeta 2. Sorry, x zeta 2. While for 3-point, okay, quite similar with 2-point. Basically, we will have zeta 1, zeta 2, and zeta 3. So this coordinate will become x zeta 1. This one will become x zeta 2, and here will become x zeta 3. So what is this zeta? Basically, zeta is the location of the integration point relative to the center. If we look at 1-point Gauss quadrature, because it say integration point location relative to the center, since this is the center, so for 1 point, this is the x zeta 1. Okay, so similar with 1 point, for 2 points, if let's say this is the center, because we are going to consider 2 points, so relative to the center meaning from here to here, its center, which is this one, and from 1 to the center, so the center location would be here. So this is the area of zeta 2, and this is the area of zeta 1. So I guess now you can imagine for 3-point Gauss quadrature, So the first point is going to be between the center of between these two, which is here. So this is zeta 1, and here is the zeta 2, and this is zeta 3. So how do we basically solve using Gauss quadrature? This is the important point. So from the example just now, let's say this is x zeta 1, and here this is x zeta 1 and x zeta 2 for 2 points. So by changing from two-dimensionless coordinate, so we can get x zeta is equal to 1 over half 1 minus zeta x naught plus 1 plus zeta xn, which brings us to the integration. So to solve the integration, final one is xn minus x naught over 2 multiplied by I zeta, where the I zeta is given by the integration limit between the dimensionless one, upper limit is 1, lower limit is -1, phi zeta d zeta, whereby this phi zeta is actually yx. So in the end, we will get R1 phi zeta 1, or I can write it as R1 yx zeta 1 plus R2 yx zeta 2 plus, if we cover until 3-point Gauss quadrature, and in the end it will become R3 yx zeta 3. So this is how we're going to get the I zeta. And once you got the I zeta, whether it's 2 points or 3 points, so for example, this is the I zeta for 2 points, while this plus this is actually the I zeta for 3 points. So once we got this value, we can replace this back here, and by putting the upper and lower limit from the original coordinate. So just now I give an example of f4 and 1, so we can get the integration. Now let's look at an example. Before we go and have a look at the example, you might wonder, what is this R value and what is the zeta value? So we can get the value of R and zeta from the table of integration points and weak factors, whereby n corresponds to number of points. So if we are considering Gauss quadrature 1 point, the zeta would be 0, where the location is 0, which corresponds to the center, and its corresponding R value is 2.0. For 2-point Gauss quadrature, we will have two values of zeta, whereby for 2 points, zeta 1, if we look here, this is the area of zeta 1. So since it is in the negative region, thus zeta 1 for 2 points will become 0.57735 negative value, while zeta 2 will become positive 0.57735, as shown in this picture. So this is zeta 1, which is located in the negative region, while zeta 2 is located in the positive region. And how about 3-point Gauss quadrature? So if we look at 3-point Gauss quadrature, as I mentioned just now, this is Zeta 1, this area is Zeta 2, and this area is Zeta 3. So if you can see here, Zeta 1 is located in the negative region, while Zeta 2 is located in the center, so it will become 0 because the center between -1 to 1 is 0. While Zeta 3 is located at the positive region. So again, the value for 3 point, so Zeta 1 is equals to negative value of this. Zeta 2, as I mentioned, is in the center, so it becomes 0. And Zeta 3 is in the positive region, so it is the positive value of this one. And its corresponding values for R, because this R is actually the weighting factor, so it is not affected by the region. So for 2 point, R will become 1, and R2 will also become 1, which is located here for 2 point. And for 3 point, the corresponding R is 0.556 here, while for R2, it is this value 0.889, and for R3, it is the value of here, which is 0.5556. Alright, let's look at an example in order to enhance our understanding on Gauss quadrature. So, let's say approximate the integration of for 1 x over square root x plus 1 dx using a 2-point Gauss quadrature and b 3-point Gauss quadrature. So, as we know, for 2 point, straight away we know that we need to find Zeta 1 and Zeta 2 because it has 2 points. So, from this Zeta 1 and Zeta 2, we can get the phi Zeta 1 and also phi Zeta 2. And once we got the value of phi Zeta 1 and phi Zeta 2, from there we can find the I Zeta, which is a combination of R1 phi Zeta 1 plus R2 phi Zeta 2, and from this I Zeta. So for 2 point, maybe I'll write it here. I Zeta. Okay, basically this is the process, yeah. So for I Zeta, for 2 point, it will become R1 phi Zeta 1 plus R2 phi Zeta 2. And as we know the I Zeta, we can straight away find I, whereby I is actually xn minus xo over 2 multiplied by the I Zeta. So basically this is the step. For 2 point Gauss quadrature, we know that we will have Zeta 1 and Zeta 2. From the zeta 1 and zeta 2, we can find the phi zeta 1 and phi zeta 2. And once we got the phi zeta 1 and phi zeta 2, we can straight away find the I zeta. And from the I zeta, we can find I, whereby I is actually xn minus xo over 2 multiplied by I zeta. So that is for 2 point. So for 3 point, we know that we were going to have zeta 1, zeta 2, and zeta 3. So similarly, from zeta 1, we will get phi zeta 1. From zeta 2, we get phi zeta 2. And from zeta 3, we will get phi zeta 3. So from all of these, we can get the I zeta, whereby the I zeta is actually given by, for 3 point, R1 phi zeta 1 plus R2 phi zeta 2 plus R3 phi zeta 3. So from the I zeta, straight away input this in this equation and we can find the integration of the function. So basically that is the process. So let's do this example. So for 2 point Gauss quadrature, first, we write the information that we have. We know that we need to identify the xn and x0, in which xn and x0 is given in here, whereby xn is the upper limit while x0 is the lower limit. So for 2 point Gauss quadrature, for this example, the xn is equals to x0 is equals to 1 and xn is equals to 4. So as I mentioned, for 2 point, we need to determine zeta 1 and zeta 2. So zeta 1, if we refer for 2 points, if you refer to the table, the value of the corresponding zeta is here. We know that zeta 1 is in the negative region, so it will become negative 0.577, while the zeta 2 is located in the positive region, so it will become positive 0.5773. So zeta 1 is negative 0.57735. I'll use 5 decimal point. And its corresponding R value from the table is 1. Thus, x zeta 1 is equals to half 1 minus zeta 1 x0 plus 1 plus zeta 1 xn. Where do I get this equation? It is basically from here. Okay, so we input all of the information that we have. 1, because negative minus meets with negative, so it becomes positive 0.57735 multiplied by x0, so x0 value is 1, so multiply by 1 plus 1 minus 0.57735 multiplied by 4. We'll get the answer of 1.633975. So once we determine the x zeta, determine the phi zeta 1, which is y x zeta 1. Maybe I'll change the color. make sure you see the step. So next we determine the phi zeta 1, which is equals to y x zeta 1. So the function, we call back the function. So the original function is x over square root x plus 1. So for x zeta 1, it will become x zeta 1 over square root x zeta 1 plus 1, which is 1.633. This is the value of x zeta 1, 633975 over square root 1.63395 plus 1 is equals to 1.00679. So we have done for zeta 1. So since 2 points, let's do for zeta 2. Zeta 2, because it's in the positive region from the table, so the value is 0.57735 and its corresponding R2 value is 1. So x zeta 2 is half 1 minus zeta 2 x naught plus 1 plus zeta 2 xn. So by inputting all the values, 1 minus 0.57735 multiplied by 1 plus 0.57735 multiplies by 4. By using our calculator, we'll get 3.366025. Next, we need to determine the phi zeta 2, which can be known as yx zeta 2. So call back the function and it will become x zeta 2 over square root x zeta 2 plus 1. So this value is corresponding to here. So it becomes 3.366025 over square root 3.36025 plus 1, which is equals to 1.61092. So now, basically, we have determined the phi zeta 1 and phi zeta 2. Next, we need to determine the I zeta. So, I zeta, because 2 point, we know that it is equals to R1 phi zeta 1 plus R2 phi zeta 2. So, R1 is 1, phi zeta 1, phi zeta 1 is this value. So 1.00679 plus R2 is again same 1 multiplied by phi zeta 2, which is this value 1.61092, and by using our calculator we'll get 2.61771. So now we have determined the I zeta. So next we need to determine I, where I is given from here. So we know that I is equals to xn minus x naught over 2 multiplied by the I zeta. So the upper limit is 4 minus the lower limit is 1 over 2 multiplied by I zeta, which is 2.61771. So the answer is equals to 3.9266. So So basically this is the integration. So again, I want you to do by yourself, solve this using 3 point. As I mentioned, 3 point will start with zeta 1, zeta 2 and zeta 3. Next, we need to determine phi zeta 1, phi zeta 2 and phi zeta 3. Then from here we can get the I zeta, and from the I zeta we can find the integration by using this equation. So that's all from me. Hope to see you again next time. Thank you very much. Bye.